All right, so we are hitting Algebra 2, Review 1 through 30, Part 2. 16 was a really similar question to this in terms of it's needing to be simplified and we need to find an excluded value. New class, new questions, even new things here. But when we look at something like this, what is an excluded value? I mean, I'm not going to be tested. I know the answer. Why would a value be excluded? It's what? It's not needed? No. An excluded value. When is something not allowed? Hey, do we ever... Go ahead. When it equals 0 in a specific scenario, right? When can we not have an answer equal 0? Or when can we not have 0 in a certain spot? Anybody? There's one specific place where zeros are not allowed. Look at this question up here. What is that? I mean, in its most general form, what is this right here? If you don't know it now, you're not likely to know it tomorrow. What is that? Bingo. That's a fraction. Okay? You said 0 is not allowed in the numerator. Which one is it? Is it the numerator or the denominator? What is it? The bottom. What is the name for the bottom of a fraction? The denominator. All right, so eventually we got there, right? Zeros are not allowed in the denominator. If you plug them in your calculator, you can take 0 divided by 0 and it'll give you an error message. In fact, anything divided by 0 is an error, right? It's not possible to divide by nothing. Does that make sense? So when we're talking about excluded values in a scenario like this, we're saying is that there has to be some values, if we were to plug them in for x, would cause the denominator to equal 0. Are we understood? So we have this 3x squared plus 6x minus 9. Is there any way of simplifying that at all? I'm probably not asking the question rhetorically. A bunch of you are saying there's no way to simplify that. Can't do anything with it. What do you notice about the numbers 3, 6, and negative 9? Wow, wouldn't that make it simpler if I divided them by 3? All right, what do I get whenever I divide all of those by 3? All right, and how could I use this, which is a lot simpler than what we started with, to solve for instances where a value input for x could cause the denominator to equal 0? Can we simplify that at all? What do we call unfoiling something? This is something after it's been foiled. What do we call it whenever it's been unfoiled? Factor it. Do we know how to factor this? What does it look like whenever we use the term factor, but what does that look like? It is multiplication, but what am I drawing up here first to help us out? Parentheses. Okay, and I'm going to go a step further and say 2 sets of parentheses. Okay, now we want to unfoil it. What are my first 2 terms in each of those sets of parentheses? X and x, very good. All right, so what are my inside operations? Adding and subtracting, because I need to multiply 2 things to get a negative, and the only way to do that is to have a positive and a negative. Things that multiply to be negative 3 but are going to add up to be 2. Three and negative 1. Very good. Okay, so my factors are x plus 3 and x minus 1. We're getting really close to finding out what these excluded values are. I'm really just a couple of things away. right? What do I do with these now to find out what those excluded values are? Solve for x? Yes. How? Put them both equal to 0. X plus 3 equals 0. Good. X minus 1 equals 0. Okay? Now what? Solve. Cool. Subtract 3. All right. In fact, what we're saying is that x cannot equal negative 3 and x cannot equal 1 because those numbers would cause the denominator to equal 0. Correct? All right. So my excluded values are 1 and negative 3. Right? Yeah. Now, our problem is that there's more than one answer. B and D both have those excluded values. So we haven't, we've narrowed it down, but we're not done yet. Does that make sense? Okay. So although you're going to need to see all this work, and when you go back and you watch the video, you can pause it, you can write all of this down. For now, I'm going to erase a good chunk of this. Okay? All right, we're going to be okay? Okay. All right, so we've got this answer. We can hold on to that. Now, the rest of this requires us, once it's simplified. Well, what can I take out of all of that? I can take a 3 out of all of it. All right, leaving me with what on the top? 1 minus x, right? Over, well, what did we have down here whenever we factored it? Can we go ahead and go back to our factored form? What was it, x plus 3, x minus 1? Okay. Let's see. And so you would probably think it's D. What is the solution on this? Is it D? Is D the answer? Huh? It's B. So how is it that we found D, but the answer is B? What's that? Well, what we want to do is that we don't really ever want 1 minus x. We would want negative x plus 1. But so here, we took out a positive 3, didn't we? Well, what if we had taken out a negative 3, right? We've got 3 minus 3x. What if we took out a negative 3? Divide all of that by negative 3. What is 3 divided by negative 3? Negative 1, okay? Well, let's put that there instead. What's negative 3x divided by negative 3? X. We'd get x minus 1, right? So I would cancel out, we're factoring out that negative 3, and what I would have is x minus 1 over x plus 3 over x minus 1. All right, what happens to the x minus 1s? They cancel out, and I'm left with 1 over x plus 3. And that's why, and we have that negative from here sitting right out there. That's how I get that instead of this. Okay? Because we want it to be positive x plus or minus. Okay? All right. 18. The area of a rectangle is equal to x squared plus 23x plus 123 square units. If the length of the rectangle is equal to x plus 12, what expression represents the width? So what they're saying is that x squared plus 23x plus 132, okay, and one of the factors is x plus 12. Okay, well then the other factor has to go here, right? And if it's plus plus here, it's going to be plus what over here? Plus minus? You think so? Plus. So really all we're looking for is 12 times what is 132? Or all I really have to do is take 132 and divide it by 12. 11. So x plus 11 is the other factor, and we can even see that if we go ahead and we FOIL, we're going to get 12x plus 11x. 12 plus 11 is 23, which works here. 12 times 11 is 132, works there. X times x is x squared, works here. Does that make sense? Now, what kind of work do I need to show for that? All right, the work that I would like to see for that is where you actually FOIL x plus 12 and x plus 11 to show that it does in fact equal this. Can you do that? Okay. All right, so now we're kind of doubling back around to questions that showed up earlier in the review. Calculate the percent change from 70 to 105, tell whether it's increase or decrease. What's my formula for this? Do you have all the right parts? Two of them are in the wrong place. New minus original over original. And we should be able to make some common sense out of this just so that we avoid making that mistake. All right, we're going from 70 to 105. So should this be a percent increase or decrease? Increase, right? But if we did it wrong, right, we would do original minus new, right? Right? We would do 70 minus 105, right? And we would wind up with a negative even though we're increasing, right? That should tell me, if I stop and think about it, that didn't work, right? So what we want is new minus original over original. So our new number is 105 minus 70, which is going to give me a positive value, over 70, okay? 35%, 35 over 70. Okay, so we got 35 over 70, which is what, 0.5? 0.5, which should be a 50% increase. Okay. Right, you want to show as much work as you can there, because if you accidentally say, you picked 50% decrease by accident, you just happen to click on the wrong button, right? If you don't have enough there, right, I won't be able to overturn your wrong answer. Does that make sense? Now, if you have plus 50% or 50% increase and you just accidentally click decrease, right, I can overturn your incorrect answer, okay? But if you don't give me enough to go on, it will stay wrong even if you got it right intentionally, okay, or at the beginning. 20. If the linear system below is consistent and independent, determine if it's consistent and independent, consistent and dependent, or inconsistent. If the system is consistent, give the solution. All right, well, we should already know that it's consistent, correct? Because it says if the system is consistent, give the solution. Well, we should know that there's a solution here because there's only a solution when they cross. All right, so we know it's consistent, right? In fact, that only eliminates that right there. Okay. If you remember on the last test, we had two equations of two lines, and it actually came out to be the same line, right? And they were consistent dependent, correct? So what should these be? Consistent and independent. Okay? Because they're two separate lines, right? They're not dependent upon one another. They are independent from one another. But they are consistent. All right, so now we just need to find a solution. What is the solution of two lines that cross? Not of all lines, okay? There's not like one solution, but where's the point of the solution? Where they intersect at, right? The XY coordinate pair where they intersect. Well, where do these lines intersect at? 0, 6. Okay? Because we can see it, right? It's not going left or right at all, so 0, and it's going up 6, crossing right there. Okay? Now, if I wanted to prove that, right, I could plug in 0, 6, and show the math to work it out. Okay? Now, let's say they didn't give me a graph, but they did give the equations of the two lines. We could do 1/3 times 0 plus 6 equals -3 times 0 plus 6. All right, well, zeros are going to cancel these out, and we're going to see that 6 equals 6. All right, so obviously the 0 coordinate works. Okay? We plugged in 0 in for x because where they cross is at the x coordinate is 0. Okay? That's why I plugged in 0 for the x values. All right. Let's see. Let's clear this out. Keep going here. Solve the system by graphing. What do I need to do with those equations first before I can graph them? Solve. There's actually two different things that we could do. Okay? What we could do with these is we could solve for their x and y intercepts and graph those, right, for both sets, or we could solve them each for the slope-intercept form and graph those. Which would you rather? Slope-intercept form, okay? So we have negative 2x plus 5y equals negative 15. We need to get that in slope-intercept form. How do I do that? Annalise, what's the first step? Add? Sure, add what? Add, well, we don't want to add negative 2. We just want to add 2x, okay, because we want to move it to the other side. Okay, so we got 5y equals 2x minus 15. Chandler, what's next? Divide by 5 on both sides. What am I dividing by 5 on the right-hand side? Okay, right, everything. So I need 2/5 x, right? And what's negative 15 divided by 5? Negative 3. Okay, so I should be able to come in here, right? Plot negative 3 there, go up to 1, 2 over 5, 1, 2, 3, 4, 5, right? Up to 1, 2, 1, 2, 3, 4, 5, go back to 1, 2, 1, 2, 3, 4, 5, down to, right, something like that, where I can get that line right there, correct? All right, now let's take that second equation. Negative 12x plus 10y equals 10. Ashley, what do we do first? Sure, add 12x to both sides. It's going to give you 10y equals 12x plus 10. Okay, divide by 10. Okay, y equals 12 divided by 10. They're both divisible by 2, 6/5. 6/5 x plus 1. Okay, so I got a positive 1 intercept, but I'm going down 6. So I'm going to come 1, 2, 3, 4, 5, 6. Oh, I'm sorry. Don't want to do that. Okay, down 6 over 5, right? Oh, wait. Is that positive 6/5 or negative 6/5? Positive 6/5. So really what I want to do is I want to go down 6, sure, but I want to go back 5. Does that make sense? So down 6, down 1, 2, 3, 4, 5, 6 over 5, 1, 2, 3, 4, 5. That's my point of intersection. Huh? All right. So instead of going up 6 over 5, right? Because if I keep going this way, right, I'm going to go off the graph, right? And honestly, they're probably not going to cross that direction. So I can go backwards, which would be to go down 6 and back 5 instead of going up 6 and over 5. Okay? And that gives me their point of intersection, which is what, negative 5, negative 5. That's my point of intersection. Okay? And you can continue to go, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Just use something like that. Okay, that's what that line continues to do. All right, so if you get something like this tomorrow, there'll be graph paper in the back, so you don't have to try to make your own graph type of thing. Okay. We're going to leave this space right here to work out number 22. We've got an absolute value, wants us to graph the solution. Anytime I have absolute value, how many solutions should I get? 2. Okay. Let's see. So tell me what the first equation I need to start with is. Okay, and what's the next one? Greater than or equal to negative 2. Okay, got to have both those things. Flip the sign, change the value. Now what? By? Subtract 1, so x is less than or equal to what? 1 over here. X is, okay, and if I'm going to graph it, okay, we've got to first have our 0 in here. We've got 1 and negative 3. 1, 2, 3. Open circle or closed circle? Okay, on both. Okay. X is less than 1 but greater than negative 3. Are those lines converging or going apart? Converging. Okay, so I should get something like that. Okay. All right. We're good here so far? Okay. All right. Again, I like this nice big empty space to work with. X squared minus 8x plus 16, and it says factor it. So we want something like that. What are the first two terms in this? X and 4. That's what you want? Okay, x and x. Okay, it's minus plus, so what should my inner signs be? Plus, minus, somebody says? Somebody says minus plus, minus minus. Why minus minus? Can you explain? What's that? Whenever they do what? Why? When does it make a positive? All right. So because it's not plus plus, all right, anytime it ends in plus, it is either plus plus or minus minus, okay? Because there's only 2 ways to multiply 2 types of numbers and get a positive. That's either to multiply 2 positives or to multiply 2 negatives. And if this sign over here is a negative, if it goes negative plus, it has to be negative negative because I can't add 2 positives and get a negative answer. All right, so it's got to be negative negative. All right, now I need to be able to multiply 2 numbers to get 16, but combine them to get 8. All right, 4 and 4, right? And I believe what they're actually going to look for on an answer like that is x minus 4 squared because it's the same thing. All right, if it duplicates, you put them back together and you show it squared. Okay, does that make sense? Okay. All right. 24. A line has a slope of 12. It passes through the point 0, negative 16. What is the equation of the line written in slope-intercept form? There is one formula we need to use here. Does anybody know what it is? Okay, I'm hearing it back there. Y minus y1. Perfect. That is exactly right. Very good. Okay. So we're going to come back to this. We've got slope of 12. We've got coordinates at 0, 16. What am I going to sub 12 in for? M? What am I going to sub 0 in for? X1 and negative 16? All right. So I got y minus negative 16. It's important that you have both negatives there, right? Equals 12 times x minus 0. All right, what's after that? Jacob James, what do you think? What would you do next? You want to give it a shot? Please. Distribute the 12, very good. All right, the only way we get better is by trying. Okay, so we got y. I'm going to go ahead and, can I make that plus 16? You don't mind? Okay, plus 16. All right, tell me about distributing the 12. What happens? 12 times x is good. And 12 times 0. 0, there's nothing to do there then, right? Okay. Let's see. Bree, what would you do next? Subtract 16. Subtract 16 from what? Anything in specific? Am I subtracting it from 12x? Nope. Right? Because whenever it comes to adding and subtracting, they have to be like terms. So what we could have done is we could have just left this as 0. That probably would have helped. Right? See that? But we're going to have 12x minus 16. Okay? Does that make sense? See, some of you guys can do more than what you think. Questions there? Okay, am I going too fast for anybody? Okay. All right. 25. 25 and 26, you can use your graphing calculator for. Okay? But you have to know how to use it. Okay, one of these questions is on the test. Okay? I'm going to show you or tell you how, so that you need to take this and put it into a 3 by 4 matrix. Okay, in this case, it's going to be 3, negative 3, negative 3, 36, negative 4, 5, 1, negative 28, 6, 1, 1, 16. Right? That's what you're going to write on the test. And out over here, you're going to say RREF, and then you're going to show me what you get. And it should give you an identity matrix. It'll look something like this, followed by 3 numbers over on the far right-hand side that will represent X, Y, and Z. Okay? That's what your work is going to look like. Okay? Do you guys know how to do this? Or do you need to see it? Okay? I'm going to do the first one, number 25 up here for you. You guys need to practice on 26. Okay? All right. So I'm going to hit second matrix. I'll wait for some of you guys to get settled in here. We're going to do number 25, and then you guys are going to do number 26. Okay? All right. So let me go back out here just so everybody understands the process. Jacob, you got a calculator? Yeah. Okay. All right. So we're going to hit second matrix. Everybody should be able to get that. We're going to go over to the right to edit. We're going to make the matrix. Now the first thing it asks for is it wants the dimensions. All right, it's rows by columns. So we have 3 rows by 1, 2, 3, 4 columns. So we want 3, enter, 4, enter, and then it should go ahead and set us up. Now we're going to go across the top row, then the middle row, then the bottom row. Okay, so we want 3, enter, negative 3, enter, negative 3, enter, 36, enter. Okay, did it right, drops down to the next line, negative 4, enter, 5, enter, 1, enter, negative 28, enter. 6, enter, 1, enter, 1, enter, 16, enter should be our last one. Okay, so our matrix is complete. So everybody understand those steps. Okay, we're going to hit second mode. That's going to take us back out here, back out to our main page. We're going to go back into our matrix portion, and we want to go over to math. Now, there's a couple of things that this little math section does is it basically allows us to pick what we want to do to that matrix. You notice that the very first selection is DET, which stands for determinant, so I can use that to actually find the determinant of those pesky 3x3 matrices if I want to check my answer with the calculator. Again, it doesn't replace showing your work, okay, but it does make sure that I got the right answer. Okay, we don't want that one for this, though. We want to go all the way down to something called RREF. It should go down to 10, and then AB, we want B. And we're going to hit enter, and we're going to go back into our matrix, and we're going to select matrix A, which we just made. Right, notice that it gives me that nice identity matrix of 1, 0, 0, 0, 1, 0, 0, 0, 1, and it tells me that X is 4, Y is -1, and Z is -7. Is that the answer according to the answer key? Yes or no? It is? All right, great. That's what it'll look like in the graphing calculator. 4, -1, -7. So we got 4, -1, -7. Right? That's what I want right there for X, Y, and Z. Order from, it went X, Y, Z from left to right, so it's going to be in order X, Y, Z, top to bottom. Yes? Okay. Well, I'm going to stop the video right here. You guys are going to work out number 26. Make sure that you know how to do it. I'll get to you in just a second, okay? All right.